Hello everybody, welcome back to another TerrNav video. Today we're going to be going over special case bearings. And there are 5 classes of special case bearing that you can be using. So the first one is the 22.545 special case. In that situation, your distance run over your square root of 2 is your distance abeam. Time run over square root of 2 is your time until abeam from your second bearing. And then your distance run is your distance off at the second bearing because it's a double the angle on the bow situation as well. So your second case is 26.545. In that situation, your time run is your time until abeam. 1.41421 times your distance run is your distance off at the second bearing. And your distance run is your distance off abeam. Your third case is your 30/60/90. In that situation, 0.866 times your distance run is your distance off abeam. Your time run over 2 is your time from your second bearing to abeam. And the fourth case is double the angle on the bow, where your distance run is your distance at the second bearing. Oftentimes you have to use that information and then apply trigonometry to find other related factors. We'll get into that later. And then the final one is table 18, where you have any other case. Table 18 is going to give you 2 values. Your first one is your multiplier for your second bearing to find your distance for your second bearing, and then your second number is your multiplier for the distance abeam. So without further ado, let's get into some problems. So our first problem, we have a course of 297.0 degrees true, speed of 11 knots. At 0019, we sight a light bearing 274.5 degrees true. At 0048, we sight the same light bearing 252.0 degrees true, and we're trying to find our distance abeam and our time abeam. So first thing I have to do is I have to figure out the distance that I ran over that time. So 48 to 19, 48 minus 19 is 29 minutes, divided by 60 minutes in an hour is 0.48 hours, times our speed of 11 knots is 5.3 nautical miles. And now I have to figure out what type of case it is, or if it's even a case at all, by figuring out what the distance, or the difference between our course and the bearings are. So 297 minus 274.5 equals 22.5, and 297 minus 252.0 is equal to 45 degrees. Well, that to me looks like a 22.545 special case. Well, what do we know about a 22.545 special case? Well, we bring this back. We know that our distance run, or sorry, our distance abeam is equal to distance run over the root of 2. Our time abeam is equal to our time run over square root of 2. And we know that our distance run is equal to our distance at the second bearing. So with that information, I'd say we can pretty easily solve for these values. So our distance abeam, we're going to take our distance run, which we determined was 5.3 nautical miles. So 5.3 divided by the square root 2 gives us 3.7 nautical miles. And what's our time abeam? Well, the time run we determined was 0.48 hours, so 0.48 hours divided by square root of 2 is 0.339 hours times 60 is 20 minutes, so we're going to add 20 minutes to that, which gets me to 0108. And just for fun, because this is a 22.545 special case, we can also figure out what the distance at the second bearing is, and it's just our distance run, so the distance at the second bearing is just 5.3 nautical miles. Cool. Now you could sketch this out if you wanted to. I find just doing the math is easier, but it's an option. Okay, so our second problem here, we're going to start by doing the exact same thing. So figure out what our distance run is and figure out what the difference between the bearings are. So that looks like, to me, a 26.545 special case. So we're going to take our review sheet out again. We know that our time run is equal to our time abeam. we know that 1.414 times the distance run, the distance at the second bearing. And we know that our distance run is equal to our distance abeam. So let's do some math here. Distance abeam is our distance run. So if we ran 7.4 nautical miles, our distance abeam is just going to be 7.4 nautical miles. And we know that our time run is our time abeam. So our time run was 21 minutes. So it's going to be 21 plus 2018. So 18 plus 1 is 20, 39. And that's what the problem's asking for, but we can also figure out what our distance at the second bearing is. So let's say distance at the second bearing is 1.41421, so 1.41421 times our distance run, which was 7.4 nautical miles, gets me 10.5 nautical miles. Okay, so in our next problem here, we're given our course, our distance run, 2 times and 2 angles. Keyword here is on the bow. So I'm not doing any sort of angle calculation because I know that we've effectively doubled the angle on the bow, right? 34 to 68 is doubling the angle. And I'm asked to find the time abeam. Well, I know that in my special cases, doubling the angle on the bow tells me that my distance run is my distance off at the second bearing, but that's not going to tell me anything about the abeam situation. So what I have to do in this situation is I have to sketch it out and I have to do some trig. It's unfortunate, but it's really the only way to solve this. So again, running 316, but I'm drawing it as 90, but it's just for the purposes of drawing it. My first bearing is 34. My second bearing is 68. We'll call this 34, we'll call this 68, and we know that this is 5. And we know that the distance run equals our distance at the second bearing. So this is 5. Well, to me, that looks like some basic trig. We know that cosine of 68 is equal to the adjacent side, x over our hypotenuse, which is 5. So 5 cosine of 68 is 1.87. So that means that this distance here is 1.87 nautical miles. And we have to figure out what our speed is. So our speed is going to be the time it took us to go those 5 knots. So 33 minutes, right, because 7 plus 26 divided by 60 is 0.55. And we did 5 nautical miles in 0.55 hours. Gives me 9.1 knots. And then I got to figure out how long it's going to take me to do 1.87 nautical miles at 9.81 knots, or sorry, 9.1 knots. I've been doing too much physics lately. 1.87 divided by 9.1 is 0.21 hours times 60 is 12.3 minutes, which is really, for our purposes, 12 minutes. So 21, 26 plus 12 minutes is equal to 21, 38. So that's our time abeam. That's probably the most complicated type of question you're going to get asked, just because it's not like a plug and chug formula thing. You have to use the formula to figure out that, and then from there you have to use trig to figure out this, and then you go from there. Okay, so this is another type of problem down here. We're looking for the distance abeam, so we're going to start using the exact same situation, figure out what our distance run is and what the different angles are. Okay, so we come up with 31 and 49 degrees. Well, that's not a special case. There's nothing that I can do formula-wise to figure that out. So that means that I got to use table 18 in Bowditch. So we're going to pull up Bowditch. And we notice that we've got more problems than we had to begin with, because 31 isn't on here, and 49 also isn't on here. So that means we have to do a little bit of interpolation. So we know, as I discussed earlier, that the second value is the one dealing with a beam. So what I'm going to do is I'm going to average the values for 30 and the values for 32. So the values for 30 are 1.20 and 1.43. And the values for 32 are 1.12 and 1.31. So we're going to average these two, and then average the result. 1.265. So that's going to be our multiplier. And we know that our distance run was 2.9 nautical miles. So 2.9 times 1.265 is 3.67, which will round to 3.7 nautical miles. Now we're going to do one last example here, and by process of elimination it has to be 30, 60, 90 because that's the only one I haven't touched on yet. So course is 90, 120, that's 30, 90 to 150 is 60. And our speed is 12 knots, so because I know it's already 30, 60, I'm just going to calculate our distance run, and then we can find our time of beam and our distance of beam. And then we know, if we pull up our 30, 60, 90 rules here, 0.866 times our distance run is our distance of beam. Our distance run is 4.8, which means that our distance of beam is 4.8. Our time run over 2 is our time from a second bearing to a beam. So we know that our time run was 42 minus 18. 24 minutes divided by 2 is 12 minutes. 12 minutes plus 42 is 54. So 0.254 is our time beam. Okay, so that's it for special case bearings. Those are the different classes of special case bearings you can find. If there's any errors that I made, or if you have any suggestions for other things that I can cover, I'll have a video on compasses and TV MDC conversions coming out probably sometime next week. It seems like I'm making these videos weekly now, so other than that, have a great day. Bye.